Wiz, today we're going small but deep, right?
Yeah, pretty small. But that doesn't mean not mighty or not powerful.
That's right. That's right. We've got some searching and researching to do today to figure out what's really going on with small agents and agent frameworks today. And there's been a special release this week, in case people didn't catch it. It was called DeepResearch, right? And then Hugging Face and the team over at Smolagents went on a mission, a 24-hour mission to recreate and go deep with Smolagents. Tell us a little bit about what they built and why Smolagents was the right tool for the job at the right time.
Yeah, basically, when OpenAI released DeepResearch, right? I think this really positioned Smolagents to have a little moment in the sun due to the fact that it is a lightweight framework that you can build agent systems with. There was just a big agent system released. There's been a bunch of open source reasoning models released, right? So as a kind of perfect storm aligned for Smolagents to have a little moment of sunshine.
Yeah. That's right. And I mean, how perfect is it that we got to do Smolagents this week? Really, really, really awesome. Thanks, for joining us, everybody. Today, we've got a much cooler event than we actually thought we were going to be able to put together, because we've got the latest release from Hugging Face. You're going to walk us through exactly how they implemented the open source version of DeepResearch today. Is that right, Wiz?
Indeed, I am, Greg.
Amazing. Okay, well, we've got a lot to sort of set the tone here, because there's one key thing that we're also going to learn along the way, and that's the code agent. And it sounds simple, and it kind of is, but it's also kind of hard to really grok. It's an agent that writes code, right?
I mean, more importantly, it's an agent that thinks in code, right? It's an agent that produces code to be run, as opposed to an agent that, we're going to learn all about it from you, Greg, but, an agent that produces stuff that runs code or can be used to run code. We're taking out the middleman. Yeah.
That thinks in code. All right. So that's going to be something that you guys understand by the end of the session. Again, thanks for joining us. We've got a special one for you today, Wiz. We'll see you back in a bit. We've got a few discussions throughout. We've got a lot to cover today. Thanks for jumping into YouTube Live today. If you have questions along the way as we cover Smolagents and the open source DeepResearch framework that was released yesterday, please do throw them in the Slido link in the description box. And if you want to chime in during discussion time, you know what to do on the live chat. All right, guys, let's go ahead and get into Smolagents and open source DeepResearch. Okay, so today we want to really align ourselves to a couple of different things. We do want to understand the Smolagent framework. We want to definitely walk away with that. And we really want to understand code agents. This is a word that we're going to start to see being used more and more. And it's one that I wasn't familiar with just a week ago. So I'm really excited to share what I've learned with you guys about code agents and how they're different from sort of the traditional agents. We're also going to learn how Hugging Face actually built the open source DeepResearch tool. Wiz is going to walk us through the repo and put it to good use today as we build, ship, and share with small while going deep. So what we want to do is we want to talk about Smolagents, then we'll sort of set the context with code agents before introducing the DeepResearch idea and the subsequent product launches from different folks related to DeepResearch. All right, Smolagents. On some level, it's just another agent framework, all right? And really, that is a very solid way to look at it. There's lots of these today. They have a common role to play. And it's more about what you use them for than it is about exactly what goes on underneath the hood. And importantly, as we've seen this week, it's important what the folks who have built the frameworks are using them for too. So smol is like small few lines of code. Smolagents. How small? Well, not that much code. All right. So when you look this up, though, you'll see a couple of key features. You'll see, hey, it's simple. It's got first-class support for code agents. And of course, it integrates with the Hugging Face hub. Duh. And it's agnostic. So shout out to Hugging Face for also being model agnostic for closed source models. So you don't even have to use open source models to use Smolagents, something I'm sure they had to do. And then, of course, you can use different modalities, different tools. Today, we're going to focus much more on the code agent piece than on any of the other pieces. But, if you want to use stuff from the hub, you want to pull models from there, obviously, super easy to do. If you want to use OpenAI or Anthropic, you can use that stuff as well. There's a lot of different ways to go ahead and leverage this library. But again, all the frameworks kind of have this as well. It's easy to very, very quickly run. And this is something I think that is typical of some of the more lightweight frameworks that we'll see out there, like the Crew AI kind of stuff, where we have kind of just a couple lines of code here. So model, agent, boom, code agent. And in this case, we're going to do agent.run. How many seconds would it take for a leopard at full speed to run through Pont des Arts? This is this bridge right here. How long would it take a leopard to run across it at full speed? And you can kind of see this very easy command line interface setup where we've got sort of step one. It's like, or the step 0 is kind of like the bridge. How long is it? Step 1 is like leopard. How fast is it? Step 2 is like, well, I got bridge and leopard. How do I convert the speeds and print the final output? And step 3 is just giving this final output. 9.63 seconds. It's pretty high. Very easy command line agent implementation. Very cool. Very small. Now, again, you could easily switch this up to any of your favorite inference providers or LLMs, like everybody's favorite these days. And here it's important to sort of remind ourselves, like, what is the idea of an agent exactly? Well, we want to think about agents, and at AI Makerspace, we like to define agents as a system that can leverage reasoning to make dynamic decisions in an application flow. And when we think about multi-agent systems, we can extend this directly. So here we're talking about a system that can leverage reasoning from multiple independent agents to make dynamic decisions in an application flow. Interestingly, we really like how Hugging Face is starting to get into the agent game as well. If you read their blog on Smolagents, you'll see they define AI agents as programs where LLM outputs control the workflow. Workflow is a word we're starting to see more and more when it comes to agents, which is reasonable. Enterprise workflows are becoming more and more of a buzzword, but application workflows is exactly where we're all working as AI engineers today. Further, they go on to say that agents are useful when you need an LLM to determine the workflow. And there are different ways that obviously LLMs can do this, can support this. Smolagents calls these agency levels. And the agency levels are sort of out of 3 stars here, where this first one would be sort of you're just simply processing an LLM response, simple input output. The sort of equivalent here in like a LangChain would be a simple chain, for instance. And then we sort of can step it up, and then we can do some routing. So if you're familiar with multi-agent setups that use a supervisor, They're just sort of routing, and they're deciding on some basic flow properties. Which direction am I going to go? Who am I going to send this to next? Which tool am I going to pick up? Which tool am I going to pick up is the next piece of this, where I'm actually not just deciding where to push something and routing it, but I'm actually doing a function call. I'm doing the reasoning and the action to go execute that thing. And so sort of rather in sort of a graph context, rather than sort of I'm just going along an edge and I'm routing along an edge, I'm actually hitting a node and I'm running something in the node. And then, of course, you can have multi-step agents and multi-agent. And this is where we get into more autonomy and more sort of decision-making and more reasoning, more action with agents. Now, that's not surprising because agents are simply a pattern. And they fundamentally are really talking about this pattern of reasoning and action. Famous paper from October 2022 kind of laid this out, and we continue to see this more and more today. Reasoning traces help the model induce, track, and update action plans. And then we can take action against those plans as we interface with different sources of information or even completely different environments. Now, this type of agency level idea, it's not new. There's been a lot of different agent frameworks and orchestration tools that have put together similar things. This one's from LangChain, and they call them levels of autonomy in that space. But we're really talking about the same thing. Wiz, I want to bring you up here for a quick discussion. So I'm seeing a lot of commonalities here. Is it really just basically just another framework? Are these things all the same, or are they all different? What's the real deal?
Yes. So the answer to your question is yes. They are all the same, and they are all different. The thing we can think, so there are parts of them that must be the same. We send input to the LLM, we receive output from the LLM, right? So that in that sense, they all communicate with some API LLM provider or locally host, whatever it happens to be. So they all communicate with an LLM, sure. The way that they handle intermediate steps, et cetera, can be extremely varied based on the implementation. So as we're seeing with smol agents, right? This code agent is a not novel, but it's very, very much leveraged in this framework when compared to something like a LangChain or a Crew AI. The way they shuffle data around, they consider data, they think about all these things is different, right? So yes, they're all the same,
Yeah.
right? But also they're not the same.
Yeah.
Right.
Okay,
so
okay. Well,
it's the worst answer I know, but it's what's true. Yeah.
I mean, this is what people want to know, though. It's like, I mean, smol agents also very dope name. I even like saying it, so that's cool. When people are thinking about, which one do I use? I mean, smol agents just came out. Should I just use that one? What's a way we can think about this as builders? Just, what's the update for February 5th, 2025?
Yeah, like the way I would think about agent frameworks right now is we're still very much in the Wild West. Pick your favorite one.
Yeah.
Right. So like pick the one that you like the most for whatever reason. Pick the one that you think is coolest, that helps you produce meaningful, useful, value-adding applications the fastest. We're not really at a point in time yet, I would say, where like one is clearly dominantly the best. There are some there are some situations where I might say like, the more mature frameworks perhaps are closer to production ready, right? The more Crew AI folks, right, are more like meant for these kinds of very exploratory prototypey workflows. But overall, they're all going to let you do similar things in similar ways. and it's just up to what you work fastest in. I'm going to say things like LangGraph is a great tool that helps you bridge from prototype to production, right? And so once you're when you're trying to build something that's supposed to be slammed by thousands of users a minute, maybe that's a good first tool to pick up. But if you're building something like deep research in 24 hours, the smolness of smol
that's right.
It's definitely worth something, right? So, yeah,
indeed. Okay. So smoly moly, maybe if you're vibing with it, but wild west. Okay, thanks, Wiz. That's a great segue into the next part of our discussion. Let's go back to what was said in the blog here, shall we? Agents are useful when you need an LLM to determine the workflow of an app. They go on to say that, but agents are often totally overkill. This is something we see in practice and in our courses as well. It's cool to apply agents, even if you don't have to. That's just where we are today. Further, they go on to offer a clarifying question that you should ask. Namely, do I really need flexibility in the workflow to efficiently solve the task at hand? Now, this is a very, very important question for you to ask, especially if you're building for production. And it's an important question for us to consider today in the context of code agents. So we've been known to say things like, when you look at something like LangGraph, we can think of it as agents with access to tools can help us solve problems. Whereas in the more kind of prototypey space of a crew AI, rather than defining an entire problem, we want to maybe focus in on the specific task. And a problem space and a task space are a little bit different. One has more flexibility. One's going to be a little bit more complex. One needs to have a little bit more, flexibility to efficiently solve the problem versus, let's say, the task. Let's think about when we ask a question to an agent system. It's going to go to the agent. The agent's going to maybe take some actions. An action or two might get pushed back into the conversation thread before we get our answer. Those actions are typically going to be tool calls, external tools or APIs that we're hitting and we're using to get data. We're using to make observations. We're using to get new results. We're using to plug back into our thinking and our reasoning before we take more actions. And importantly, this sort of action piece in the middle here, this is done with a fine-tuned LLM. It's fine-tuned to do reasoning and action in one single step. That fine-tuning is called function calling. It's fine-tuned to literally write JSON and call functions. So we can think about function calling as the sort of reasoning and action in a single step. We give it an instruction, and then it's going to go call the tool, get something back. Agents, oftentimes today, we can think of them as giving the LLM access to tools, and we can call them. So is that different than code agents? Yes. Let's talk about code agents. Let's go back to this first-class support idea for code agents. And let's dig in a little bit deeper to what Hugging Face has to say. In a multi-step agent, at each step, the LLM can write an action in the form of some calls to external tools. Okay, so we just saw. Dope. What does that look like? Well, this is from a paper called Executable Code Actions Elicit Better LLM Agents. This is not a typo. This is February 2024, a year ago. Getting some traction now. LLM agent using this text or JSON as an action. Instruction: determine the most cost-effective country to purchase the smartphone model. Terrible, terrible name. 1. The countries to consider are US, Japan, Germany, and India. So let's look and see what happens here. Well, we get an output at the end, and the output says something like, the most cost-effective country to purchase the smartphone model is Japan, price of $904. Now, what happens in the middle? Well, we take a little reasoning step. I should calculate the phone price in USD for each country. Yeah, dope. Action, boom. Tool, lookup rates, country. Environment, action, environment, action, environment, action. So then I'm going and I'm interacting with some external tool or environment. I'm getting some result back, and then I'm taking another action. I'm doing the thinking, and then the action and the interaction with the environment. And this lookup rates for country Germany is followed by a lookup phone price for Germany, is followed by a convert and tax, is followed by a dot 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 dot. A lot of action calls here to get the final response. A lot of action calls. Why so many action calls? Well, this is the agentic setup that we know and love. This paper, this work, proposes to use executable Python code to consolidate LLM agents' actions into a unified action space. That sounds dope. What does it look like? Well, instead of one step of action, each single little thing, each tool call, I can actually do one single action step based on the reasoning and the thinking that I'm doing here. Now note, I have exactly the same tools here. So if you look closely, you'll see lookup phone price. I can see lookup phone price. If you see convert and tax, I can see convert and tax, and so on. Now, what happens here is different. Here, I'm doing the thinking and I'm writing the Python code that uses all the tools in the right order to answer the question. Boom, same answer. This is a very powerful pattern for obvious reasons. And it's not something that I think many of us have thought deeply about. So it's something really worth paying attention to. I think we'll hear more and more about code agents. Because what we get is we get better composability. This is a buzzword we see everywhere with orchestration frameworks. If we think about, if we wanted to actually, nest function calls within each other, or we wanted to put a bunch of function calls that we would put in the same order together, we could easily compose these sort of processes with our tools, right? If we wanted to, let's say, store each of the outputs of the individual actions versus store one output of a code agent action, which one's going to be easier to deal with? Obviously, the generality is pretty clear here. And, if we look at LLM training data, we actually have a lot of it that we have quality sort of code action already baked into. And, obviously there's been a lot of code LLMs that help us write code as humans. This is different than the code agent we're talking about today. So the way we can kind of think about this is the code agent is just going to pick up all the right tools and it's going to just write the single action step code. Give it the problem, give it the tools. I don't need a step-by-step detailed process breakdown. I'm a professional, okay? I'm a code agent. Just tell me what the problem is and I'll solve it. So in the end, we see that code agents do their thinking in code. That's what we said at the beginning. I hope it makes more sense now. We can think of it as an alternative to function calling. All right. And with that, let's talk about deep research. Hard pivot into what are the top use cases for LLMs today? What are they? And let's think like, how can code agents maybe help? Well, if we look at reports like, best of 2024, 2025, we see stuff like document parsing and analysis. And look at this. We see this down here, research automation. Let's specify the question further. What are the top use cases for LLM agents today? What's an agent again? Remember, it's a system that can leverage reasoning to make dynamic decisions in an application flow, make dynamic decisions. I can control the workflow with agents. And I should be asking myself, do I really need the flexibility in the workflow to be able to efficiently solve the problem or task at hand? Well, we talk to folks like LangChain, LlamaIndex a lot, and you can look at their top AI agent application use case. It should be no surprise. We see research and summarization. We also see personal assistance and productivity as number 2. These are pretty close. Interesting. Let's talk about deep research from, of course, everybody knows, Google. December 11th, 2024, deep research uses AI to explore complex topics on your behalf and provide you with findings in a comprehensive, easy to read report. Wait, deep research from Google? Yeah, that's right. This was dope all the way back in December. I remember I saw this come out and I was telling everybody about this. This was freaking cool. I mean, they told us in the blog, they told us it creates a multi-step research plan. Once you approve, it begins deeply analyzing relevant information. They didn't tell us much about how they built it, but they told us what it did. And curiously enough, they called it your personal AI research assistant, right in line with exactly what we would expect top agent use cases were in 2024. Fast forward nearly 2 months, February 2nd, 2025, OpenAI releases, Chad move, OpenAI, deep research. Deep research is OpenAI's next agent that can do work for you independently. You give it a prompt, and ChatGPT will find, analyze, and synthesize hundreds of online sources, creating a comprehensive report at the level of the research analyst. Oh my gosh, what a novel idea. They tell us a little bit more about what they did here. To accomplish this, it was trained on real-world tasks requiring browser and Python tool use. Aha! Using the same RL methods behind OpenAI 01. You see, OpenAI 01, it's dope, but many real-world challenges demand extensive context and information gathering from diverse online sources. Wiz, let's do a quick discussion here. How many flavors of reasoning do we need to solve problems? I mean, do we really need all of this stuff? Is it distinctly different, a deep research versus an 01, even though it's trained the same way?
Yeah, so they're not. So it's interesting. So maybe they're trained the same way, but they're not trained the same things, not trained to do the same tasks. And it's this idea that we have these super big, super generalist systems that we're now trying to specialize. We're trying to make best at specific things, and that's kind of where these flavors of reasoning come in. We don't need to have this kind of like STEM, reasoning flavors when we're talking about, like writing cool stories and books, similar a la Deep Writer from Garrett, community member. We need that for things like producing research or trying to push the needle on some math. So these different reasoning flavors are what's going to allow us to have a suite of specialized models that we can tie together, likely through some complex agentic system that we will be more useful than the sum of its parts.
So what's the common thread here between like an O1 and like a deep research? I mean, we see this sort of reasoning model. We see this reasoning action with agents. Are we doing a sort of similar chain of thought thing where we're finding a bunch of, potential sources that give us the right information and then collating them? And I mean, what's your understanding? Obviously, they haven't sort of put out the official paper on this yet, but
Yeah.
what's the high level understanding you have of how these things are trained?
Well, think about it from this perspective, right? So so chain of thought training, this kind of like R1 approach, right? Which is this, OpenAI is all but confirmed is what they used for O1. The kind of RL style training. It makes the model think more, right? But like thinking more is only one half of like a real system to system, right? We want to have something like search, the ability to go out and seek information and then synthesize it. And that's where things like deep research come in, right? They build a system that both benefits from the test time scaling of just a model produces more thinking tokens. More thinking tokens we've found leads to better reasoning. And then we're also tacking on top of it like some kind of search system where we can say, okay, well, let's go out and explore. Let's go out and understand, from external sources, new information, try to synthesize that, confirm, fact check, verify, these kinds of things that aren't possible with just the model outputs, right? As advanced as an O1 model or R1 model can be, it can't like search Wikipedia, right? Like without some kind of system that lets it do that. And this is the idea of these kind of deep researchy systems, that they augment even further the test time scaling, right? Than the model does by itself.
Okay, so if we put this in the context of Smolagents and specifically of these code agents that we're talking about today, is your understanding that code agents are being leveraged to build these models, or that these are more leveraging just classic tool calling, function calling?
There's no evidence. What I can tell you about Smolagents is that it's still writing code to use tools to augment the context, right? Like that is the thing that it's doing. You can use bigger, better, faster, stronger models with the open research or open deep research Smolagent implementation, of course. But the guts of it is still a agentic system that's searching for information and then relies on some LLM to synthesize the response. That's the pattern.
Okay, it's agentic, but is it code agentic?
It is code agentic. Yeah, it is. It is.
The words. Oh my God. Yeah, I don't know how we can get a handle on these things. Well, okay, it's time to introduce Open Deep Research. Thanks, Wiz. We'll be right back to you to walk us through what's going on under the hood. But for this quick intro, let's just remind ourselves of the clarifying question. Do I really need flexibility in the workflow to efficiently solve the task at hand? If I do, I should consider agents. Open Deep Research. Yesterday, from the blog, OpenAI released DeepResearch, a system that browses the web to summarize content. The system is impressive and blew our minds when we tried it for the first time. So we decided to embark on a 24-hour mission to reproduce their results and open source the needed framework along the way. In this blog, it was cool to see Hugging Face define the idea of an agent's framework. Maybe this brings a lot of our discussions today together. A layer on top of an LLM to make said LLM execute actions and organize its operations in a series of steps. Is that happening in a code agent context? Is it happening in a function calling context? Let's go ahead and dig into smol DeepResearch with the Wiz to find out. Wiz, over to you.
Oh yeah. Okay, so here we have it. Open DeepResearch. Free the AI agents. This is the thing we have. We'll start up a new input here, and we'll just say like what is the latest state of the art 2025? Yes, I know you're trained in 2023, but it's 2025 now, right? We gotta say this in order for the agent to understand that it's not currently 2023. When it comes to LLM reasoning models, please provide a markdown report outlining the approaches and how they work. Also rate how cool they are with a lit factor score with a fire emoji. So we can fire that bad boy off, and we're going to see that our agent is going to start working. Now, the big idea of the day here is that we don't have a specific objective other than this. The rest of this is being handled by our agent, which is going to be working on and on in the background. So we're going to just let that cook. And while it does, you can tell, it's like a cooking show. We've already prepared for you the full response, because it does take some time, right? Makes sense that it would take some time just based on the fact that it is doing some deep research, right? But the idea is that firstly, what we do is do a web search. And the way we do a web search is with this, with this code, which we execute, right? And then we can see that we have this execute logs, which is just going to be our web results. Now, this is the thing about the code agent. The tool is Python interpreter, right? But what it's done is it's written code to be executed, by the interpreter. So whereas we have traditional kind of flows for agents where we say like, okay, you're going to use a tool, which is some function. I'm going to give you the payload for that function. You're going to call it. And then we keep repeating that process, right? What the code agent does instead is it writes a whole script that can potentially call all of, some of, one of, three of the tools that we have access to and combine them together into a single coherent script. This is much, much more effective, as it turns out through some research that Hugging Face did, at these kinds of tasks, right? And this is because we're allowing the agent to build the function, the Python function that does what it needs to do all together, instead of kind of doing this translation back and forth, code JSON. Okay, so we do some search. That's cool. You love doing some search. We get the search responses, and then we say, okay, well, we want to do some more code. So what we're going to do, again, is just build some code. We have a Python interpreter. Our Python interpreter is going to do something and return some response. And then we're going to go to the next section. And then we're going to go to the next section. And then we're going to go to the final section where we get our report, where we have, the top models are Llama 3.1, 405 billion, 4 peppers, DeepSeek R1, 674 peppers. Everything's equally lit except for Claude doesn't get the nod. Sorry, Claude. You'll notice that there is still some rough edges here, right? I mean, you can tell it's built in 24 hours. This is not the quality of report that you'd expect from a deep research. But again, it was done in a day, right? And it's already quite good. There's a lot of places we can think to improve, but that's it. So this is great. How does it work? Well, first of all, of course, it's built on Smolagents. Smolagents is Hugging Face's agent library, as Greg already explained. We've got a bunch of cool stuff. All the credit to Hugging Face's Smolagents for this one. All right, so how do we actually let's get a grounding in Smolagents, right? Let's understand briefly something we can do with Smolagents. So what we're going to do is we're just going to grab our OpenAI API key. We're going to grab our code agent and our light LLM model, and we're going to have an agent type of agent text. And we're going to set up our light LLM model to point to GPT-4o, which is going to consume our API key. Pretty normal stuff here. And then we're going to create a simple web browser. A simple web browser is just going to search the web for things. That's it. That's all it needs to do. Now, when we look at the actual, web search tool, you'll notice we're using a very familiar pattern of having a forward method, right, which is going to do something, and then we're going to set this up as a tool. So this is kind of like what most agents do, right? This is like most agents. You have tools, you set up the tools, and then you create a quote unquote tool belt. Now we can create our code agent, which is going to have our model and our tools. We're going to limit it to a maximum step of 5, and we're going to set it to the maximum verbosity so we can see all the printouts in our Jupyter notebook. And then we can finally ask the agent, right? Like, what is the latest version of Python? What are its key features? And then we can let it rip. We're going to basically see what happens, right? Now, notice that we have our initial query. What is the latest version of Python? What are its key features? What we do, instead of producing a tool call, right, we produce Python code that can use our tools. So this is the key distinction, right, that we're trying to impress upon you. That instead of a tool call, we just generate some code, and then we execute that code, right, like directly in some interpreter. And then we have some execution logs, which is just going to be a bunch of information. Very cool. And then we can go ahead and we can create new, code. So based on the search results, we want to find some difference between 3.12 and 3.13. Okay. Well, basically, we're going to be able to create lists of these things, and then we're going to be able to create lists of differences, our latest version, and then we can print these outputs, right? And then we can get this. The key features, right, are these two features. But notice how it's just executing this kind of arbitrary Python code, right? Like there's no tool call that's happening. It's tool execution. It's just writing some Python that it cooked up, and then we export it. And then we get our final answer, which is, again, just produced in some amount of code, which will tell us that the key features from Python 3.13.1 are new XML processing enhancements, as well as behavioral changes in XML processing to align with future versions. So that's like a basic code agent, right, in Smolagent. It does one thing, which is it can search the web because it has one tool. You can imagine if we give it, 6 tools here, that it's going to be able to do a bunch of different things and combine them in different ways and combine their expected outputs in different ways. And that's exactly what we see when we look at the actual DeepResearch. So this repository is available to you should you want to take it for a spin. It's basically just a repo that contains what was produced by Hugging Face with very, very little to no changes. The big thing that we want to see, though, is how this thing is working. And so that's what this is going to do. So how it works, the DeepResearch agent is powered by a sophisticated system of tools and components. But the big thing is that it does web browsing, right? So, and it does web browsing in a way that we would expect. It can visit pages, and then it can navigate through those pages in order to determine, if it's got the right information. It can kind of keep searching if it feels like it hasn't yet got that information that it needs, et cetera, et cetera. So this is the idea of the DeepResearch agent, right? It's not just that it's able to look at web results. It's that it's able to visit web pages and look through them like a human would, right? Same with document analysis. We can get a bunch of different documents that we can kind of download, and then we can look through them, including but not limited to all of the ones that you see here, which is very cool, right? Then also we can use visual processing. visual processing. So we can look at the web page, right? We can see the web page. This is still pretty experimental. They're working on it at Hugging Face Smolagents, but that's still good. And then we can see all of the different cool tools that we have, right? We've got our web search, visit page, page up and down, find on page, control F. You know what I mean? Like it's doing the same things that you would do if you were expected to do some research. Find next and find archived URL, or URL, sorry, and then inspect file as text and download file, and then of course some visual processing. The idea of how it sorts these things out is through the ability to understand what each source is saying, summarize that source, provide additional context and information about that source, dig deeper. And then this is the example research flow, which is kind of, it'll use the web search tool, then it will use visit page, look for new instances, find certain things to extract or understand from that page. And then it can use things like the visual model to analyze and understand those documents. And that's the idea. It's a relatively simple set of tools and flow, right? Like this is not, again, 24 hours. Okay. So it's not like it's not peak. It's not the best it could ever be. But with this set of tools, we can get the behavior that you saw earlier quite straightforwardly, right? And something that I want to mention lastly, we'll go back to our original Gradio app, right, where it's got it's redone it. You can see at every step exactly what it's doing. You can see at every step exactly what kinds of code it's trying to use, right? So excuse the doom scrolling here, but we have like the the visit page tool, which we can see is going to extract us information. All of this stuff is available through that simple small agent framework, and it can build this, relatively. Again, it's not 24 hours, so it could be better, but a good initial recreation of deep research. Something else that I want to point out that I just did for funsies is that the supplementary repo information was all produced by our friend Open DeepResearch. It didn't come out cooked right, so there was some editing that had to occur. Not everything ran right away. Some of the stuff that it produced was perhaps inaccurate, but the base of this stuff was produced by that actual Open DeepResearch setup, showing it's got decent flexibility again for a tool that was built in 24 hours. We're gonna do one last thing before I send you guys back to Greg, which is we're gonna look a little bit into the code. Not too overwhelming because it's small, right? But the idea is that you can see we have our scripts, which are going to be our tools, and then we have our small agent related kinds of information. The actual running of the agent is relatively straightforward. We set up a user agent, which is confusingly not related to an actual agent. This is something that lets us look at the browser, right? We set up our model and we set up our text limit, and then we have our simple text browser. We enable this with a bunch of web tools, and then we set up our code agent with the web tools, and then we simply let it go. We let it run, right? So this entire piece here, right, just going to implement each of these tools, and then it's going to we can start using it, right? With which we do through Gradio. You can see that we have our our actual call here as agent.run, right? And when we look at each of these tools, like say for instance, we want to look at the Finder tool, which we can do in our scripts folder, you'll see that they're not at all complicated, right? Like this is the tools that we're talking about. Very simple kind of basic tools that just let us look at text on a web page, but it can combine all together with a good LLM to produce the reports that we saw, the part of the notebook that we saw, and part of the walkthrough that we saw. So this is all the power of Open DeepResearch. With that, I'll send you back to Greg. But before I do, I have to ask you kindly to ring the bell icon and subscribe. We're here every Wednesday. There you go. Okay.
All right, Wiz, excellent. Thank you for that walkthrough. We learned a lot today, man. And we saw Smolagents have the code agents underneath, agents that think in code. How about this Smolagents logo too? Really, really dope. Well played, Hugging Face. Think about when you need the flexibility in your workflow before you pick up an agent. And best agent framework, pick the one you're most excited about. If you have questions, please throw them into the Slido and let us know. Wiz, first question I have for you is, as you were kind of walking through the code there, it struck me that the sort of deep research agent feels like what it's doing is it's sort of combining all of the stuff we see from like a computer use agent with like classic agent framework stuff. So it's just like, it's really meta and it feels like it's the next layer of complexity. And it feels like we're starting to get to this place where you could potentially do really complex things. Am I thinking about this right?
Yeah, we've been in the kitchen for the last 6 to 8 months on computer use. Obviously OpenAI has released like Operator as well, which we didn't get into, but is likely what's part of what's powering deep research, right? But yes, we've kind of been building all of these constituent parts and just waiting for models that were capable enough to tie all the components together. And we're seeing that at least in some cases, it's working. Now, there's a lot of rough edges, and this is extended to real deep research, both from Google and from OpenAI, same name, as well as open deep research. There's some real rough edges that we've got to fix, we got to figure out. But in terms of are agents going to be real in 2025? I think this is a very strong signal that yes, agents are something that are certainly getting to the point where we would consider them to be useful generally, even if we've still got some polishing left, let's say.
Yeah. Okay. Useful generally. First question from Anonymous here, though. Useful, but potentially dangerous, right? We've talked about this before. Like, you're just going to let it loose and give it access to everything and let her rip. We would highly recommend that you be a little bit careful. Shout out to Anonymous for the anonymous tip here, right?
Yes. They are listen, run at your own risk. If you're using local agents, Hugging Face has a good set of options for you for appropriate levels of sandboxing for these code execution agents, right? Obviously OpenAI, they're worrying about it. That's on their server, not yours, so it's all good. Right. But yeah, these systems have the potential to do harm, to be dangerous in a way that previous agent systems weren't. Though we've been doing things like Baby AGI, right, which has been doing arbitrary code execution on our through terminal and stuff like that, since whenever ChatGPT came out. So it's not novel danger, but it is still worth considering. It is still absolutely true that you should really be confident in the thing that you have before you let it arbitrarily execute code on your system.
Okay, I want to stick with this sort of what can it do theme here. We had a question from Richard in the Slido. Am I correct that we can use this as an advanced web scraper? And then we got a couple questions in the chat related to this. Can it go to a website and click a button and decide? And then where do you see within what it can do what some of these rough edges are?
Yeah, I mean, so it could be a really fancy web scraper, right? Like I think though you would want to just stick to Operator for that, right? Or just stick to the tools as opposed to this system that then synthesizes some end result, right? But yes, you can do that. Now, when it comes to clicking buttons and things like this. I mean, the Hugging Face Smolagents certainly isn't going to be doing that. Operator may be able to do that. In terms of like GDPR, TOS, stuff like this, it can only do what kind of like a normal web browsing agent can do. There is some limitations there, as well as the fact that we haven't set up the internet for agents, right? This is something that we're talking about a lot, right? Which is the idea that like the internet was set up for people, wasn't set up for computer agents that just go out and do stuff. So there's a lot of enhancements we could make, or changes we could make, or we can foresee that will make this process more guarded and better, right? So, and then rough edges. At the end of the day, the reasoning model has limits. It cannot reason, beyond its capacity, right? There are things it can't do. It forgets still. Long context is a little weird. The outputs are not always 100% grounded. It hallucinates like a lot. The lists go on. But it's not like new challenges we've never heard of. It's the same challenges at the next scale, right? So, it's not saying that like these systems are inherently more rough-edged than our existing systems. It's saying that when the systems run for 25 minutes straight without human intervention, we can see the roughness a lot easier, right? Than when we're at every single step of the process.
That's right.
So yeah.
And if you sharpen the edges on what you're trying to build, then you can eliminate that roughness.
Well, and this is the other thing too. We remember how long it took for us to understand how to prompt OG ChatGPT. Remember how long it took? Prompt engineering became a whole field, right? And this thing came out on Tuesday or wherever it was.
That's right. That's right. Yeah.
We don't even know yet how best in all cases to use it, right? And we only get 100 shots a month for people who have that access, right? So it's going to take a while to figure out, what is the best way to set this machine going, right? What's the best initial conditions, given that we know that we have this compounding error, this butterfly effect kind of happen. Initial conditions are extraordinarily important in an agent system. So it's a lot of, listen, there's work to be done, but it's exciting work to be done, right?
So we got multimodal vision LLMs. We've got these new reasoning models we don't know how to prompt yet. We've got these new small agents connect everything up together all at once. I mean, it is like, wow, it is wild, wild west. There is just a couple more questions I want to get to before we wrap today. So let's see if we can rapid fire these. These are based more on the Smolagents framework. Giorgio asked, what are your thoughts on Smolagents' faster code execution compared to other frameworks that separate prompts from functions for better organization?
Big fan.
Big fan.
I think the jury's out on whether it's generally always better or et cetera, but it is cool. The ability for the LLM to, especially as LLMs get better at writing code, the ability for them to like generate novel synthesis of these functions that we've provided them is neato at worst, so yeah.
Yep. And finally, Bob Jones, we did see it earlier. Bob's concerned about which agents will make it easiest or harder to adapt to new things in the future. Personally, I mean, I feel like they're all going to be pretty flexible and in there. What do you think about this? As somebody who's a real, scale engineering guy, we kind of understand where Bob's coming from here.
I think at the end of the day that the ecosystem is kind of coalescing on some standards that are going to make this largely moot going forward. But yeah, I mean, smaller, lighter weight frameworks or frameworks that are built for modularity are going to be give you more peace of mind in this respect. But ultimately, they're all going to be pretty straightforward to incorporate new things. There are very few that are totally locked in. I think that you want to avoid very like pre-packaged solutions if you're looking to avoid that lock-in, but those are fewer and far between these days. So yeah.
And that gets back to our earlier discussion of prototyping versus production, and maybe pick up LangChain today. There are some LlamaIndex shops, but the ones that give you sort of that maximum flexibility for production are going to be probably tools you want to look at, Bob. Okay, Wiz, thanks for walking us through everything. Awesome. Smolagents, but deep. Thank you, everybody, for joining us today to talk Smolagents and deep research. We try to keep you in the loop on what's happening at the LLM edge, especially with these new prototyping frameworks, while continuing to focus on building the world's leading community for people who want to build, ship, and share production LLM applications like you guys. If you are not yet part of our Discord community, we'd love for you to join us starting today and start building, shipping, and sharing right now. Tag at AI Makerspace when you build, ship, and share, and we'll help amplify. Also, if you're interested in really accelerating your ability to build these production-grade systems, check out our next upcoming cohort of the AI Engineering Bootcamp. It's going to be cohort 6 starting April 1st. No kidding. And if you want to start learning a little bit more about reasoning models, about exactly what's going on with some of the top headlines today, you might want to stick around on YouTube for next week when we cover DeepSeek R1. We're going to go into the training details. We're going to go into some of the controversy. We're going to go into what we know about DeepSeek. We're going to play with it. We're going to see how it compares to some of the leading models. And we'll follow that one up with more large reasoning model goodness the following week with continuous chain of thought, or Coconut, released by Meta. So stay tuned. We've got lots of state-of-the-art reasoning stuff coming up. If you want to focus more on production level stuff, jump into the Discord, check out our courses, check out some of our past YouTube events. Thanks for joining us today. We hope to see you next week. And until next time, keep building, shipping, and sharing. And we'll do the same. See you next Wednesday, everybody. Thanks for joining us.